This lesson is about combining like terms. Combining like terms is a process used to simplify an expression or an equation using addition and subtraction of what we call the coefficients of terms. So consider the expression below. These are just regular numbers, and we combine things like this all the time. We say 5 plus 7 is 12. But sometimes we have variables in our expressions, and combining those like terms are a little bit different. So an expression like this, we have some coefficients. Coefficients are the number in front of the variables. So whenever we're going to combine like terms, we're looking at two numbers that have the same variable combination on them. So we have 12 x's and we have 5 x's. Together, that makes 17 x's. And then this is what we call the constant term, and that one doesn't have anything to combine with, so it just goes at the end. So like terms just means anything that has the same characteristics. So these are all considered like terms because they have just a coefficient, but the x is the same. These are all called constant terms because they do not have an x. Now, just because this has a variable does not mean that these are like terms. The variable combination has to be exactly the same for us to call them like terms. So 2x, 2y, 3x, and x squared, let's say 2x squared. The x and the x are like terms. The y is definitely not. And the x squared term is definitely not. It has to have the exact same variable combination, including exponent, for them to be considered like terms. So when we look at this, expression 7c plus 9 minus 3c, we're going to identify the coefficients, the constant terms, the like terms, and the simplified expression. So my constants are 9. Sorry, let me erase that. That's not what I intended. My constants are my numbers. So my just plain number, no variable, is a 9. My coefficients are the numbers in front of the variable. So there's a 7, and then remember, because of add the opposite, that's really a negative 3 in front of that c. So the coefficients were 7 and negative 3. The constant term was 9. Our like terms are 7c and negative 3c, which means those are the things we're going to combine. So 7 and negative 3 makes 4c, and then we tack our constant on the end. This one, we have coefficients of 1, there is a 1 in front of that a, negative 2, and that's it. Our constant terms are the 4 and the negative 10. And see how I use my underlining to kind of highlight my like terms? It makes it a little bit easier when you get to combining. So 1a and negative 2a makes a negative 1a left over. And all I really have to write is the negative a. The 1 is understood. 4 and negative 10 is minus 6. Oops, I wrote that in the wrong blank. Getting ahead of myself. So the like terms were a and negative 2a. The constant terms were also considered like, and that was 4 and negative 10. So when I did my simplifying, I combined these and I combined these. In this problem, my coefficients are negative 3 and positive 4. My constant is positive 1. So my like term is negative 3n and positive 4n. So that's the only thing that's going to get combined. A negative 3 and a positive 4 makes a positive 1. You can write the 1 in there in front of there if you want, but you don't have to. And then that plus 1 didn't get combined with anything. All right, now this one's a little bit different. Because this has a squared, it does not match up with these guys. These guys do not have a square up here. So a squared has a coefficient of 1. This has a coefficient of 3. That has a coefficient of -2. And then our constant terms are 4 and -10. So the only like terms we have are 3a and -2a and 4, so I'm going to underline those 3 times, and -10. So when I combine, my a squared goes first. That has the highest exponent, so it's going to go first. And that's going to be followed by my 3a and my -2a, which simplifies to just 1a. And then you follow it up with your numbers, which is -6 when I combine my 4 and my -10. All kinds of different variable combinations here. So this is to the third. It matches up with this third. This squared doesn't have any partners. This m doesn't have any partners. But these are all coefficients. So I have a 5, a 2, a -7, and a -8. 3 is the only constant. However, my like terms are 5m cubed. Remember, when it's to the third power, that means cubed. And -7m cubed. The m squared, the 8m, and the constant don't have anything in common. So 5 and -7 is -2, and that's m to the third. So I've taken care of this guy and this guy. And my exponents go greatest to least, so I should follow it up with the 2m squared. And then my m. And last is my constant. And that's your simplified expression. Even more crazy. All right, now the x's and the y's have to have the same variable combination. So this x has a 2, this x has a 3, this doesn't even have an x, and this x has a 3. The y's have to be the same too. So the only ones that had anything in common right now was the x to the third and the x to the third. The y also has something in common. So the first thing we'll do is go through and look at our coefficients. There's a 5. Remember, there's really a 1 in front of here. So it's a -1, 2, and there's a +1 in front of here. We don't have any constant terms, so I'm going to write none. And this term is all by itself. This term matches up with this term, and that one's all by itself. So my like terms are -x to the third y and x to the third y. So those are the only ones that get simplified. I have a negative and a positive. So really, those just end up going away because a negative and a positive cancel each other out. So I'm always going to start alphabetical. So my x's, whichever one has the biggest exponent, goes first. So that'll be the y, 5x squared y to the third. And then even though the y had a 3, because it doesn't have that x with it, it goes afterwards. So alphabetical first, and then exponent value is what you look at. So again, alphabetical, greatest exponent to least exponent, unless you're told otherwise. So that's it for this lesson. Make sure and look at your workbook for your assignment.